Hey everyone, welcome to mini lecture number 5 in our anxiety and impulsivity unit. This time we're talking about serotonin and dopamine. So first off, how does serotonin interact with what we've been discussing? It actually modulates anxiety in a pretty complex fashion. We're not going to get too into the weeds with it. Just know that the 5-HT1A receptors receive the most attention when it comes to anxiety research. And in most cases, agonists of this receptor type have anxiolytic effects, while antagonists are anxiogenic. What happens here varies quite a bit by location. So in the hippocampus and amygdala, the 5-HT1A receptors are primarily expressed postsynaptically, so stimulation of these receptors increases anxiety, whereas in the raphe nucleus, the primary source of serotonin in the central nervous system, 5-HT1A receptors are primarily expressed somatodendritically as autoreceptors, meaning that they serve sort of a inhibitory function on the release of serotonin more broadly, right? They serve to reduce the amount of serotonin being released when they are stimulated. So this reduces anxiety. They're anxiolytic, right? So stimulation of 5-HT1A receptors in the raphe will produce a reduction in anxiety, whereas stimulation of 5-HT1A receptors postsynaptically in the hippocampus and amygdala will increase anxiety. And that might seem kind of confusing or counterintuitive, but it all has to do with how the receptors are expressed postsynaptically, amygdala hippocampus, versus as autoreceptors in the raphe nucleus. So we know that exposure to an uncontrollable stressor enhances activation of the raphe system, which will cause increased serotonin extracellularly, which will make projection targets more sensitive. So this is sort of similar to what we talked about with the CRF signaling system, where this enhanced serotonergic signaling will result in future challenges releasing even more serotonin in those projection neurons, which will further enhance anxiety. So somewhat paradoxically, and with what we've said here, where the first line of defense for anxiety is often SSRIs, though, as you might expect from what we've said, initially this might cause an increase in anxiety for some, especially those who are in a heightened state. So initially this might cause anxiety for some people who are put on it, but long-term adaptations are required for SSRIs to be effective. So there's a sort of longer induction period. So SSRIs might not necessarily be suitable for those who require immediate relief from anxiety symptoms. I also sort of want to mention as an aside that serotonin is neurotrophic during development. Without getting too into the weeds about what that means, neurotrophic just means that it supports the growth and development and differentiation of neurons. So during development, especially during fetal development of the amygdala and prefrontal cortex, serotonin's neurotrophic influence is very important. And disruption of this process can cause high emotionality and reduced volume and connectivity between the amygdala and anterior cingulate cortex. So not only do those who experience disrupted serotonergic signaling during development show decreased volume of the amygdala and anterior cingulate cortex, but also decreased connectivity between those two regions. So let's move on to our discussion of dopamine. This serves a modulatory role in anxiety. We know there are significant projections between the VTA, which is a significant source of dopamine input in the central nervous system, and to the medial prefrontal cortex, which we have discussed is really, really important for emotion regulation. So there's a lot of dopamine projections going between the VTA and the prefrontal cortex. Stress increases the firing of those neocortical dopamine neurons. So in stressful situations, we actually see increased activity of this pathway. Lesions of the VTA to amygdala reduce conditioned fear. So if you take out this pathway of dopamine originating in the VTA and being released in the amygdala, conditioned fear acquisition is impaired. Injecting D1 receptor agonists into the amygdala will increase anxiety, and antagonism of D1 receptors can produce an anxiolytic effect. So if you recall, for our open field experiments, we actually used a D1 antagonist, SCH-23390, and we co-administered that with a anxiogenic substance, caffeine. So we're currently in the process of preparing lab reports for that, but we'll see how caffeine and D1 antagonists interact in this instance. We see phasic burst firing in the VTA, which is induced by stress. So that means just as these stressors are going on, we see increased instances of transient high activity in these VTA neurons releasing dopamine. This is correlated with dopamine release, especially in the nucleus accumbens. That might be a little bit counterintuitive, as we've talked about dopamine release in the nucleus accumbens being important for reinforcement, but it's never quite so simple as just the mere presence or absence of a neurotransmitter. The timing of dopamine signaling is extraordinarily important for coding different events. So we won't get too into the weeds with that. Just know that this is a piece of information that I would like you to know. So what we can see here is that chronic activation can persist when threats are not present. So if we have chronic activation of this pathway after the threats have dissipated, this may predict vulnerability to dysfunctional responses such as PTSD or phobias. Okay, that is it for our discussion of serotonin and dopamine. We'll see you next time.